Hello everyone, so in this one shot you're going to learn about 15 problem types that can be formed from the chapter Oscillations. It is one of the most important chapter which has its application in other chapters as well. So if you watch this video till end, you will be able to answer one or two questions that can be asked from this chapter. Now I would like to emphasize on one important thing, that is going to be a revision video. So I'm not going to derive any formula, but I will see the application of each and every concept. So without any further delay, let's start the session. Hello everyone. So now first let us have a look at the syllabus. So in this chapter we have oscillation, periodic motion, then time period calculation for simple harmonic motion, then what is the frequency, the displacement of the particle as a function of time, and then what is the periodic motion, then simple harmonic motion and its equation, phase, what do you mean by phase, what is initial phase constant, then the oscillation of a spring, if a spring is connected with a block, then what is the time period of the oscillation of the block, then the concept of restoring force, what is force constant, then the energy of a simple harmonic motion, kinetic energy, potential energy of the particle which is undergoing simple harmonic motion, the concept of simple pendulum, and the derivation of the expression for its time period. So we're going to cover these 15 problem types, and I have arranged these problem types as the way we are going to teach them in a regular class. Now let us start with the very first problem type, and it is based on equation of simple harmonic motion. Right, so when a particle is oscillating, and if we plot the displacement of the particle as a function of time, then we'll get a sinusoidal curve, right? And we know the general equation of simple harmonic motion will be where x is equals to a sine omega t plus phi. Now in this equation, x is the displacement from the mean position, and in this case we have considered mean position to be origin. A is the amplitude, omega is the angular frequency of oscillation, and phi is the initial phase constant. Now let us read the question. The displacement of the particle executing simple harmonic motion is given by this equation. The time period of motion is 3.14, or you can say pi seconds. The velocity of the particle at t equals to 0. Right, so if you look at this equation, this is x. So if you want to find the velocity of the particle, we have to differentiate this with respect to time. So dx by dt will be 10 omega cos omega t plus pi by 3, and we have to find the velocity. So this is the instantaneous velocity. We have to find the velocity at t equals to 0. So it will be 10 omega cos pi by 3. Now what is omega? Time period is given, so we know that omega will be 2 pi by capital T. So it will be 2 pi divided by pi seconds, so it will be 2 second inverse. So 10 times 2, and cos 60 is 1 by 2. So it comes out to be 10 meters per second, right? So that is the answer. So now let us see the next problem. A particle of mass 0.5 kilograms executes simple harmonic motion under the force which is minus 50x. The time period of oscillation is x by 35. The value of x is, right, so here we have given force, so F is equals to minus 50x, and time period is given as x by 35 seconds, and we have to find the value of x. Now if you know, like in case of a simple harmonic motion, the restoring force is proportional to the displacement from the main position, and it is of the form of F equals to minus kx, where k is the force constant. So if we compare these two equations, we can say k is nothing but 50. And we know that if a particle is executing a simple harmonic motion, k is given as root of, k is nothing but m omega square, because omega is given as root of k by m. So mass is given as 0.5, and omega we can calculate from this equation. So this comes out to be 10. So omega will be 10 second inverse. Now from omega we can find the time period. So time period will be 2 pi by omega. So 2 pi by 10 will be the time period. So it will be pi by 5, and we have to find and this is given as x by 35. So we can say x is equals to 7 pi, and pi is 22 by 7, so the answer will be 22. So x is 22. Now let us see the next question based on the same problem type. A rectangular block of mass 5 kg attached to a horizontal spring executes simple harmonic motion of amplitude 1 meter, time period is 3.14, the maximum force exerted by the spring on the block. Now we know that force is equals to minus kx and force will be maximum when x is maximum. So here amplitude is given as 1, time period is given as 3.14. So we know that k is m omega square, or we can write this as m, and omega can be written as 2 pi by capital T. So if we substitute the values, mass is 5, 2, and pi, let us take it as pi only, and time period is given as 3.14, which is nothing but pi seconds. So this comes out to be 4 times 5, 20. So 20 is the force constant, that will be Newton per meter. And we want to find the maximum force, so F max is nothing but k times the amplitude, and k is 20 and the amplitude is 1, so it comes out to be 20 Newton. Right, so now let us see the next problem. A particle executes simple harmonic motion of the amplitude a along the x-axis. At t equals to 0, the position of the particle is a by 2, and it moves along the positive x-axis, and the displacement of the particle in time t is x equals to a sine omega t plus delta. We have to find what is the initial phase constant, right? So x is given as a sine omega t plus delta, and we have given particle is going in the positive x direction. So if I put x as a by 2 at t equals to 0, so we are getting sine delta as 1 by 2. So there are two possible values of delta. So one will be pi by 3, pi by 6, and the other will be pi minus pi by 6, because sine is positive in first and the second quadrant. So that will be 5 pi by 6. Now this value, if you take this value, the velocity comes out to be positive. If you take this value for delta, the velocity comes out to be negative, but we have given that the particle is going in the positive x direction. So delta will be pi by 6. So option 1 is the right answer. Now let us see the next illustration. In a linear simple harmonic motion, the restoring force is directly proportional to the displacement. A is correct. The acceleration and the displacement are opposite in direction. That is also correct. The velocity is maximum at the main position. It is also correct. The acceleration is minimum at the extreme position. That is wrong. Acceleration is maximum at the extreme position. So A, B, C should be the answer. Option 1 is the right answer. The equation of the particle executing simple harmonic motion is given by this equation. X is equals to sine pi times t plus 1 by 3 at t equals to 1 second. The speed of the particle, right? So we want to find the speed of the particle at t equals to 1 second. So let us differentiate this. So dx by dt will be the instantaneous velocity, and it will be pi cos pi times t plus 1 by 3. And we have to find the velocity or the speed at t equals to 1 second. So v at t equals to 1 second, let us substitute t as 1. So it will be pi cos pi, and it will be 1 by 3. So what is cos pi by 3? That will be 1 by 2. So that comes out to be pi by 2. So it will be 3.14 divided by 2, or 1.57 meter, and we have given x is in meters, so that should be meters per second, and it will be 157 centimeters per second. So option B is the right answer. Let us see the next question. The motion of the simple pendulum executing simple harmonic motion is given by this equation. Y equals to a sine pi t plus 5, where t is measured in seconds. The length of the pendulum. So if you look at this, omega is given as pi. So omega is pi, so the time period will be 2 pi by omega, which is nothing but 2 seconds. Now we have to find the length of the pendulum. So we know that the time period of simple pendulum is 2 pi times root of L by G. So let us use this formula to find the length of the pendulum. So if I square on both sides, we will get t square divided by 4 pi square times G will be length. So t is given as t is 2 square, and g is 9.8 divided by 4 pi square, right? So we have to find the approximate answer. So, and we know that pi square is nearly equals to 9.8, so we can eliminate this, and this length comes out to be nearly equals to 1 meter. So the closest answer would be C, 99.4 centimeters. Now let's see this question. The velocity of the particle executing simple harmonic motion varies with the displacement as for v square equals to 50 minus x square. The time of period of the oscillation is x by 7 seconds. The value of x is, so we have to find the time period basically. If we know the time period, we can find the value of x. So let us simplify this. So it will be for v square is given as 50 minus x square. Now what we're going to do, let us differentiate this and let us try to form the simple harmonic motion equation. So let us differentiate this. So this will become 8v dv by dt is equals to 50 will become 0 minus 2x dx by dt. Now this dx by dt is nothing but the instantaneous velocity. So this is nothing but v and this is v, right? So we can eliminate these two. So we are getting a times the acceleration of the particle, because dv by dt is the instantaneous acceleration, equals to minus 2 times x, or acceleration is minus 1 by 4 times x. So here acceleration is proportional to the displacement from the main position, and this multiple is nothing but the square of the angular frequency. So omega square is 1 by 4, so omega will be 1 by 2. Now we know omega, we can find the time period, which will be 2 pi by omega. So it will be 2 pi divided by 1 by 2, so that comes out to be 4 pi, and we know pi is 22 by 7, so that will be 88 by 7. So x will be 88. Right, so let us see the next illustration. A particle of mass 250 grams executes simple harmonic motion under the force F equals to minus 25x. So F is given as minus 25x. The particle attains a maximum speed of 4 meters per second during its oscillation. The amplitude of the motion. So we have given V max, which is 4 meters per second. And we have to find the amplitude. Okay, let me just tell you, like V max is nothing but the, if you remember the equation, x is equals to a sine omega t plus phi, then V is a omega cos omega t plus phi. So the maximum value of the velocity is nothing but a omega. So V max is nothing but a times the omega. And what is omega? So here we have force constant, right? So we know the force constant K is 25, which is nothing but m omega square. Mass is given as 250 grams, which will be 0.25 kilograms. So 25 is equals to 0.25 omega square. So omega square comes out to be 100 and omega will be 10 second inverse. Now we can use omega and substitute this in this equation, we'll get the amplitude. So amplitude will be 4 by 10, so which will be 0.4 meters or 40 centimeters. So 40 is the answer. Now let us see the next problem. A particle executes simple harmonic motion represented by the displacement x is equals to a sine omega t plus phi if the position and the velocity of the particle at t equals to 0 are 2 centimeters and 2 omega centimeters per second, then its amplitude is x root 2 centimeter, where the value of x is. So we have to find the amplitude, right? And okay, right, and it is given that the amplitude is x times root 2, and this x is not equals to the displacement or the position of the particle. This is some other x, right? So we have given at t equals to 0, x is 2 centimeter and v is 2 omega, right? So let me just substitute the values. So 2 is equals to a sine phi, and we can say 2 omega is equals to a omega cos phi, right? Now this omega will get cancelled out, and if you look at these two equations, we can say sine phi is equals to cos phi. And when do we have sine phi equals to cos phi? When phi is equals to pi by 4. Now in phi is pi by 4, we got the value of phi, and we have to find the amplitude. Okay, now what we're going to do, let us substitute phi value in this equation. So 2 is equals to a sine pi by 4. So a comes out to be 2 root 2. And it will be in centimeters. So the answer will be 2. Got it? Right, let us see the next problem type, which is based on like where we have to check whether the given equation is for simple harmonic motion or not. So here we are given y is equals to sine omega t plus cos omega t. So the most basic so the most easiest way is to differentiate the equation 2 times and prove that the acceleration is proportional to the displacement, right? So what I mean that if I prove the second derivative of y with respect to time is proportional to say minus y, something like this, then we can say the equation will be simple harmonic. Okay, so if I double differentiate this, let us differentiate this dy by dt. It will be omega cos omega t minus omega sine omega t. Let us differentiate this one more time. D square y by dt square, and this will be minus omega square sine omega t, and this will be minus omega square cos omega t. So minus omega square will be common, and we have sine omega t plus cos omega t, where sine omega t plus cos omega t is nothing but y. So d square y by dt square is equals to minus omega square y. So here acceleration is directly proportional to the displacement from the main position. So it's a simple harmonic motion. And the amplitude of the motion will be what? So let us find the amplitude. Let me simplify this. So this can be written as y. So here we have sine omega t and cos omega t. Here we have 1, here we have 1, right? So what we can do, if I divide, so 1 square plus 1 square and root of that, this will give us root 2. Now if I divide and multiply with root 2, I will get root 2 times 1 by root 2 sine omega t plus 1 by root 2 cos omega t. Now this can be written as sine omega t cos pi by 4 plus cos omega t sine pi by 4. So we got the sine A plus B formula. So that is nothing but sine omega t plus pi by 4. And if you look at this equation, the maximum value of y is nothing but root 2. So root 2 is the answer of this question. Now let us see this question. So the function of time representing a simple harmonic motion with a period of pi by omega is. So we have to find the period. So if you look at this function, it is the same function that we have studied in the last question. So it comes out to be root 2 times sine omega t plus pi by 4. So its frequency, angular frequency is omega. So the time period will be 2 pi by omega, right? So it is 2 pi by omega. So option 1 is incorrect. Now let us see the second one. Now in this case, we have 3 omegas, right? Omega, 2 omega and 3 omega. Now if you look at cos omega t, its time period, let me consider this. For cos omega t, time period is 2 pi by omega, and for cos 2 omega t, time period is 2 pi by 2 omega, and for cos 3 omega t, the time period is 2 pi by 3 omega. So if you look at the case, the maximum, if the greatest time period among these three functions is for cos this one, right? 2 pi omega. So we can say this function, the sum of these three functions will repeat themselves after 2 pi by omega. So they will be having a time period of 2 pi by omega. So this option 2 is also incorrect. Now let us see the third one. Sine square omega t. In this case, we can write this as the sine square omega t. So this can be written as 1 minus cos 2 omega t by 2. So that will be y, or we can say it can be written as y equals to minus 1 by 2 cos 2 omega t plus 1 by 2, or you can say y minus 1 by 2 is equals to minus 1 by 2 cos 2 omega t. Now in this case, it is the particle is undergoing simple harmonic motion, and where the mean position is y equals to 1 by 2 and the angular frequency is 2 omega. So what is the time period? It will be 2 pi by 2 omega. So pi by omega is the time period. So option 3 I can say is correct, but let us check option 4. So it will be, in case of option number 4, we have 3 cos pi by 4 minus 2 omega t, and we can write this as, we know the cos of minus theta is equals to cos theta, so this can be written as 3 times cos 2 omega t minus pi by 4. So we can say the angular frequency is 2 omega. Again, we are getting the time period as pi by omega, right? Right, so option 3 and 4, these 3 and 4 should be the correct, but I think as per the NTA they have given option 4 as the answer, so which is incorrect, right? Option 3 and 4 should be the answer. Now let us see this question, and this is a question based on the new problem type, which is simple harmonic motion as a projection of uniform circular motion. So for a particle P revolving round the center O with a radius of circular path R and the angular frequency omega as shown in the figure, the projection of OP on the x-axis at time t. So we have to find the projection, and we have given that it is at this particular position when the radius vector makes an angle theta with the positive x-axis. Now we have to find the position at a general time. So what is the angle? So this total angle will be, let me call this as 30, and this will be omega t, right? Because the angular displacement for the particle undergoing uniform circular motion will be omega t. So this total angle will be omega t plus 30, which is pi by 3. Now we have given, now let us take the projection. So if we take the projection, now we have a right angle triangle. Let me show the right angle triangle. So there is a right angle triangle, and this angle is omega t plus pi by 6, and the radius is given as r, and this projection will be r cos omega t plus pi by 6, right? So that will be x. So option 1 is the right answer. Now let's see this question. A point A moves with a uniform speed along the circumference of the circle of radius 0.36 and covers 30 degrees in 0.1 seconds. The perpendicular projection P from A on the diameter Mn represent the simple harmonic motion of P, the restoring force per unit mass when P touches M. Okay, right, so when P touches M, we have to find the restoring force, restoring F divided by M. And restore, in this case, if you look at the projection, the particle is undergoing simple harmonic motion from O to N, and then back to O, and then from O to M, and then back to O. And M corresponds to the extreme left position, and we have to find the restoring force. So at the extreme left, the force will be towards the main position, and it will be A omega square. And if I divide this with mass, that will be the restoring force per unit mass. So we have to find the value of this. And what we have given, radius is given, and this radius is nothing but the amplitude. So A is given to us. And we have given that the particle covers 30 degrees in 0.1 seconds. So it means omega times 0.1 omega t will be pi by 6. Now from this we can find omega. So that will be 10 pi by 6, second inverse. And what is the mass of the particle? So mass is not given, but what else we have given? So it is given that the radius is 0.36 meters. Right, let us see. So if I simplify this, it comes out to be A is 0.36 multiplied omega square. So that will be, we can write this as 5 by 3 pi. So let us multiply this. So it will be 25 pi square by 9. So mass is not given, right? Let us simplify this. So this will be 0.04, and this will give us 104. So this will become 1. So we're getting pi square by m. Now pi square is nearly equals to 9.87, right? I think they have taken unit per unit mass, okay, per unit mass. So they've taken m as 1 kilograms. So this comes out to be 9.87 divided by 1. It will be 9.87 Newton per kilogram. It should be Newton per kilogram of restoring force per unit mass, right? So option 4 is the right answer. Now let us the next problem type, and it is based on the restoring force calculation from the potential energy. So here we have given potential energy. The potential energy of the particle of mass 4 kg is in motion along the x-axis is given by this equation. The time period of the particle for the small oscillation, where we assume sine theta is nearly equals to theta in radians, is pi by k seconds, the value of k. So we know from the concept of work power energy that if we define potential energy for a given system, then there must be some conservative force, right? So work done by the conservative force can be shown in terms of the change in potential energy. So we can say the conservative force will be given as minus of du by dx in this particular case. Now let us differentiate u with respect to x. So du by dx will be 4 times 0 minus of minus 4, and this will be sine 4x. So this comes out to be 16 sine 4x. So that is du by dx. So the force will be minus of 16 sine 4x. Now we got this equation, and we have given that the time okay, right. So for small oscillation, this x will be very small, so we can say 4x is also very small. So this can be written as nearly equals to minus 16 times 4x, and this will be minus 64 times x. So we got the force constant, which is 64 Newton per meter. So k is 64, and we have to find the time period, and this k can be written as m omega square, and mass is given as 4 kilograms. Now from this, omega square will be 16, so omega comes out to be 4 second inverse. So time period will be 2 pi by omega, which is 2 pi by 4, and it will be pi by 2. So k will be 2. So 2 is the answer. Now let us see the next problem type, which is based on the relationship between the instantaneous velocity and the instantaneous position of the particle. And here we're going to use this formula that the v can be written as omega times root of a square minus x square. Now let us see the question based on this. The position, velocity, and the acceleration of the particle executing simple harmonic motion are found to have magnitude 4 meters, 2 meters per second, and 16 meters per second square at a certain instant. The amplitude of the motion is root x meter. We have to find the value of x. Okay, right. So if I write down the equation, so x is equals to a sine omega t plus phi. Let us say this is the general equation, and velocity will be given as a omega cos omega t plus phi, and the acceleration will be minus a omega square sine omega t plus phi, or we can also write this as minus omega square times x. Now let us see what data we have given. So we have given the position, we have given the value of x, and the speed and the acceleration at a particular instant. So we can say a is 16, and it will be minus omega square times 4, right? So magnitude I'm taking, right? So it should be, so omega square will comes out to be 4, so omega will be 2 second inverse, and we have to find the amplitude. Now if you look at this relation, v is equals to omega times root of a square minus x square. So if I use this relation, v is given as 2, and omega we have just calculated, it is 2 root of a square minus x, and x square, x is given as 4, so that will be 16. So from this we can say a square will be equals to 17, so a comes out to be root of 17, and amplitude is given as root of x, so x comes out to be 17. So 17 is the answer. Now let us the next problem based on the same concept. A particle executes simple harmonic motion with an amplitude of 4 centimeter. At the mean position, velocity of the particle is 10 centimeter, and we know that the mean position the velocity is maximum. The distance of the particle from the mean position when its speed is 5 centimeter per second. So we have to find the value of x, and v is given to us, and so v is given as 5, and so it will be omega root of a square, amplitude is 4, minus x square. So x we have to calculate, and maximum velocity is also given, so a times omega is given, that is 10. So from this we can find omega, so 10 divided by 4, so this will be 2.5. So we can substitute omega value in this equation, so we'll get 5 is equals to 2.5 root 16 minus x square, so this will give us 2. Let us square on both sides, so that will be 4 equals to 16 minus x square. So x square comes out to be 12, and x can be written as root of 12, which is 2 root 3 or root 12, right? So it is given as root alpha, so alpha is nothing but 12. So 12 is the answer of this question. A particle is doing simple harmonic motion and the amplitude is given, time period is also given, which is pi seconds. The maximum velocity, so V max, is when the x is 0, and it will be a omega. A is 0.06, omega is 3.14, or right. So we have to find the approximate answer, so that will be 24, and then it will be 8, and then 18. Maximum velocity we have to find in centimeters per second. 0.6 time period is given. Oh, sorry, this is time period, no? Sorry, this is time period. Omega, pi is the time period. We have to find the omega, so that will be 2 pi by time period, which is pi. So it comes out to be 0.12. So it will be 12 centimeters per second, right? So this is in meters per second. It will be 12 centimeters per second. So 12 is the answer. Now let us see this question. Two massless spring with the spring constant 2k and 2k both have the same spring constant, carries 50 grams and 100 grams mass, are at free ends. These two masses oscillates vertically such that their maximum velocities are equal. So then the ratio of the respective amplitudes. So Vmax for the first particle is same as Vmax for the second particle, and Vmax is given as a times the angular frequency. And in case of a spring block arrangement, omega will be root of k by m, where k is the force constant of the spring constant. So it will be a1 times omega 1, which will be root of 2k by 50 grams. And this will be a2 times root of 2k by 100 grams. So this 2k will get cancelled out. This will give us 2 here. So we can say a1 by a2 is equals to 1 by root 2. Right? So that should be the answer. But I think there may be some misprinting. This is 2k and 2k, right? If we have 2k and 2k, the answer should be 1 by root 2. So none of the option is matching the answer. Maybe I think this spring constant will be different in this question. So it should be the answer, right? So we have to find the ratio of the respective amplitudes. Now let us see the next question. On the same problem type, when a particle executes simple harmonic motion, the nature of the graph of the velocity as a function of displacement, it will be an elliptical path, elliptical shape. Why? Let us see. So V square is equals to omega square times a square minus x square, or we can write this as v square upon a square omega square equals to 1 minus x square by a square, which is x square by a square plus v square by a square omega square equals to 1. So we can say it's an ellipse. If this is the x-axis and this is the velocity axis, and we can say the semi-major axis will be nothing but 2a, or a basically. So this point will be a comma 0, and this will be minus a comma 0, and semi-minor axis will be 0 comma a omega, and this will be 0 comma minus a omega. So it is an ellipse. So you can remember this, right? So option B is the right answer. A particle is making a simple harmonic motion along the x-axis if at a distance x1 and x2 for the from the mean position, the velocities of the particles are v1 and v2 respectively. The time period of its oscillation is given as. So we have to find the time period, and we have given v1 and v2 at x1 and x2. So we can say v1 can be written as omega times root of a square minus x1 square. Similarly, v2 can be written as omega times root of a square minus x2 square. Now we have to find the time period. So basically we have to eliminate amplitude. So what we can do, we can write this as v1 by omega square plus x1 square is equals to a square, right? Similarly, we can also write this as v2 by omega square plus x2 square as a square. Now from this, we have to find the value of omega. So we can say v1 square minus v2 square divided by omega square will be equals to x2 square minus x1 square. Now from this, omega comes out to be v1 square minus v2 square divided by x2 square minus x1 square root of this. So let us see the option. And this is the omega, and the time period will be 2 pi by omega x2 square minus x1 square upon v1 square minus v2 square. Let us see the option. Option 4 is the right answer. Okay, let us see the next question. The same question we have just discussed. It came in two different shifts. The answer will be elliptical. A simple particle executes simple harmonic motion. The graph of velocity as a function of displacement. Again, it will be an ellipse. Same question, but in a different shift. A particle executes simple harmonic motion with an amplitude a and the time period is v. The displacement of the particle when its speed is half of the maximum speed. So what is the maximum speed? It is a omega. That is v max. And we have given speed is half of the maximum speed. So we can say a omega by 2 will be equals to omega times root of a square minus x square, where a is the amplitude. So omega will get cancelled out. Let us square on both sides. So that will be a square by 4 equals to a square minus x square. So x square comes out to be 3 by 4 a square. So x will be root 3 by 2 a. So if we compare this, the answer comes out to be 3. So let us see the next question. It is based on the problem type where we have to find the time interval between the two positions. A simple harmonic oscillator has an amplitude A and the time period is 6 pi seconds. Assuming the oscillator starts from the main position, the time required by it to travel from x equals to a to x equals to root 3 by 2a will be. Okay, let me just tell you the trick how we can do this by using the concept of uniform, taking the projection of the particle having uniform circular motion. Let us try to do this by that particular technique. So I'm taking the particle like it is starting from the topmost point and it is going in the clockwise direction with an angular velocity omega. And we have given that we have to find the time required by it to travel from x equals to a to x equals to root 3 by 2a. Right, or right. So when this particle say reaches at this particular point, then its projection will be this, right? So can you see the projection of this particle is undergoing simple harmonic motion. As this particle goes in the clockwise direction, the projection will go in the right direction and then again in the left direction, and it will keep on oscillating. Now here we have given it is going from x equals to a. So when the particle is at x equals to a to x equals to root 3 by 2a. Let us say the projection here, this length is root 3 by 2a and this length is a. So what is the angular displacement? Let us say this angular displacement is theta. So theta will be angular velocity times the duration from say point A to point B, right? Okay, let me call this is P to Q. Right, now what is this theta? That theta we can find by trigonometry. Can you see this right angle triangle? And the radius of this circular path will be nothing but the amplitude. So in this right angle triangle, we can find the theta. So this is the theta and this is root 3 by 2a and the radius is a. So we can say cos theta will be base upon hypotenuse, and this will give us root 3 by 2. So it means theta is nothing but it's an acute angle. So theta is 30 degrees or pi by 6. So we can say pi by 6 is equals to omega t, and what is time period is given, and omega is 2 pi by capital T. So that will be 2 pi by 6 pi. So it comes out to be 1 by 3. So let us put omega as 1 by 3 second inverse. So 1 by 3 times t is equals to pi by 6. So t comes out to be pi by 2. So x will be 2. So 2 is the answer. So this is the way we can find the duration between any 2 points in simple harmonic motion. Now let us see the next problem based on the same concept. A particle executes simple harmonic motion. Its amplitude is 8, time period is 6 seconds. The time it will take to travel from its position of maximum displacement to the point corresponding to half of the amplitude. Right, so again let me show you by with the same approach. Like there are multiple ways to solve such kind of a question, but this is one of the easiest approach without any mathematics. Very less mathematics is required in this approach. So amplitude is given, so the radius will be 8 and time is 6, and we have to find from maximum displacement to the point corresponding to the half of the amplitude. Let us say from this position to this position, right? And in this case, let us take the particle going in the anti-clockwise direction. So particle starting from this and its projection in the x direction gives us the projection in the x direction is simple harmonic. So this will be a by 2 and this will be a, and when the particle reaches here, then the projection will be at a distance a by 2 from the center. So we can say the angular displacement, this is the angular displacement. So we can say theta will be omega times the duration. Now this theta we can find by trigonometry. So cos theta will be base upon hypotenuse, which is a, so it will be 1 by 2. So theta will be pi by 3. So we can say pi by 3 is equals to omega, time period is given, so that will be 2 pi by 6, and t, so from this will give us 2, so t comes out to be 1 second, right? So 1 second is the answer. And some standard durations you can remember. So if there is this is the path followed by the particle which is undergoing simple harmonic motion. This is x equals to 0, this is x equals to minus a, this is x equals to a, and let me take this as x equals to a by 2 and this point as x equals to minus a by 2. Now the time taken by the particle from mean position to a by 2 and from a by 2 to mean position, that will be t by 12. And the time taken by the particle from a by 2 to a and back to from a to a by 2 will be t by 6. And from 0 to minus a by 2 or minus a by 2 to 0, it will be t by 12. And from minus a by 2 to minus 8 and back from minus a to minus a by 2, it will be t by 6. So this you can remember where t is the time period of one oscillation. Right, let us see the next question based on the same concept. The displacement of a simple harmonic oscillator after 3 seconds starting from its mean position is equals to half of the amplitude, the time period of the harmonic motion. So it says in from t equals to 0 to t equals to 3 seconds, the displacement is, so x becomes, so at t equals to 0, x is a by 2, half of the amplitude. Right, so okay, right, this can be solved by using the equation of simple harmonic motion. So x is given as a sine 2 pi by capital T times small t. So that is the equation, and the displacement becomes a by 2. So a by 2, a sine 2 pi by t, that is capital T is not given, that we have to calculate, and small t is 3. So this comes out to be So sine like 1 by 2 we will get there are two possible answers. It can be or we can say 2 pi by t times 3. It has two possible values. So first will be 1 by 2 30 degrees, or you can say pi by 6, or pi minus pi by 6. Okay, right. So let us try to find. So 6 pi by t equals to pi by 6, or 6 pi by t is equals to 5 pi by 6. So this will give us 36 seconds, and if we use this value, it gives us 36 by 5, which is 7.2 seconds. So we can say option, so 36 should be the answer, right? So D option is the correct answer. Now let's see the next question. A particle performs simple harmonic motion with a period of 2 seconds. So time period is given. The time taken by the particle to cover a displacement equals to half of its amplitude from its mean position is 1 by a. I told you the time taken by the particle to cover displacement equals to half of its amplitude from the mean position is t by 12. Okay, and this t by 12 and time period is given as 2, so that will be 2 by 12, or it will be 1 by 6. So A comes out to be 6, right? 6 is the answer. A particle executes simple harmonic motion between minus a to plus a. If the time taken by the particle to go from 0 to a by 2 is 2 seconds, then the time taken by the particle in going from a by 2 to a. So what we have seen, time from 0 to a by 2 is t by 12, and this is given as 2 seconds, so time period will be 24. And from a by 2 to a, we have seen it is t by 6, which will be 24 by 6, so it will be 4. So option 4 is the right answer. Now let us see the next question. So y is given as a sine omega t plus phi naught is the time displacement equation of simple harmonic motion. At t equals to 0, the displacement of the particle is y equals to a by 2, and it is moving along the negative x direction, then the initial phase angle. So it says, if I show the path of the particle, so this is x equals to 0, and this is x equals to a by 2, and the particle is going in the left direction. So the position is a by 2. So we can say a by 2 is equals to a sine phi, right? At t equals to 0, we can plug in the values. X is a by 2, time is 0. So from this, phi has two possible values. It will be pi by 6 or pi minus pi by 6. Okay, now if we use this value and we'll try to find the velocity comes out to be positive, but we have given velocity is negative, so this should be the initial phase constant. So 5 pi by 6 should be the answer. Time period of the simple pendulum is capital T, and the time period to complete 5/8 oscillation starting from the mean position is alpha by beta t, the value of alpha. So 5 by 8th oscillation. Okay, right. So let us see what they mean by that. So 5 by 8 can be written as 4 by 8 plus 1 by 8. Right? So 4 by 8 is nothing but half oscillation plus 1 by 8th oscillation. And 1 by 8th oscillation is nothing but half of the 1/4 oscillation. So we can say, so particle goes from the mean position to the right and comes back, so that will be half oscillation, and then 1/8. So what is the 1/4 oscillation? Like from mean position to the extreme left or extreme right, that is 1/4, and half of that. So it means the particle is reaching at this particular position. That will be x equals to minus a by 2. Now let us find the total time. So we know that from mean position to extreme right, the time taken is t by 4. So t by 4 plus t by 4. So this will be t by 4. This time will be t by 4. So we got t by 2. And this time will be from mean position to minus a by 2 is t by 12. So t by 2 plus t by 12 it will be the time taken by the particle to have 5/8 oscillation. So this will be 7 by 12t. 7 by 12t, and we have to find the value of alpha. So alpha is nothing but 7 and beta is nothing but 12. So 7 is the answer. Now let us see the next problem type, where we are changing the speed of the particle at a particular position while it is performing simple harmonic motion. A particle performs simple harmonic motion within the amplitude A. Its speed is increased to 3 times at an instant when its displacement is 2a by 2. Let us see. The new amplitude is na by 3. The value of n we have to calculate. This is x equals to 0. This is x equals to a. And when the particle was at x equals to 2a by 3, at this instant, what is the velocity? So let us see, at this instant we can find the velocity, which will be omega root of a square minus x square, which is 2a by 3 square, right? So this will be omega root, a will come out, so 1 minus 4 by 9, so that will be omega a times root 5 by 3, right? So that is the speed at this particular instant. Let me call this as v naught. So this is v naught. Now we have changed, its speed is increased to 3 times. Now this velocity has become 3 times v naught. So 3 times v naught is omega a times root 5. Now we have to find the new amplitude. So I'm assuming that the angular frequency doesn't change. We are only changing the speed. Okay. So what will happen in this case? If we again use the same formula, v equals to root omega root a square minus x square. So this v will become 3v naught. Omega will remain as it is omega, and a will become the new amplitude, and the x is nothing but 2a by 3, right? Now let us simplify this. So 3v naught is omega a times root 5, and this is omega root of a prime square minus 4a square by 9. Omega will get cancelled out. Let us square on both sides, so that will be 5a square equals to a prime square minus 4a square by 9. Now from this we have 5 plus 4 by 9, a square is equals to a prime square, and that will be 49 by 9, a square is equals to a prime square. So a prime comes out to be 7 by 3a. So n is nothing but 7, right? Now let us see the next question based on the same concept. A body is performing simple harmonic motion with an amplitude of 10. The velocity of the body was tripled by air jet when it is at 5 centimeters from its mean position, the new amplitude. Again, based on the same concept, so I'm just keeping this as a homework for you. You have to apply the same concept that we have studied in the last question. So now let us see the next problem type, which is based on the energy in simple harmonic motion. Okay, so when a displacement of a simple harmonic oscillator is 1/3 of its amplitude, the ratio of the total energy to the kinetic energy is x by 8, where x is. So here we have given x is a by 3, and we have to find the ratio of total energy to the kinetic energy. Okay, first let me tell you what is kinetic energy, potential energy, and the total energy. So kinetic energy is given as half k a square minus x square, where this k is the force constant, right? And this is the kinetic energy. And the potential energy, if you assume that when the particle is at the main position, potential energy is 0, in that case we can say it will be half k x square. And if we want to find the total energy, let us say E is the total energy or mechanical energy, that will be half k a square, right? So we have to use these three formulas if you want to find the energy as a function of x. So ratio of total energy to the kinetic energy. So total energy is half k a square, and the kinetic energy will be half k a square minus a square by 9. So this half k will get cancelled out. A square will also get cancelled out. So 1 upon 1 minus 9. So that will be 9 by 8. So 9 is the answer of this question. Now let us see this question. In a simple harmonic motion, the total energy of a given system is E, if the mass of the oscillating particle P is doubled, then the new energy of the system for same amplitude. So we know that the mechanical energy is given as half k a square, right? So it depends upon the amplitude and it depends upon the force constant, and we are only changing the mass, we are not changing the force constant or the spring constant. So the mechanical energy will not change. So the answer will be option 1. An object of mass 0.2 kilograms executes simple harmonic motion along the x-axis with a frequency of 25 by pi hertz. At the position x equals to 0.04 meters, the object has a kinetic energy of 0.5 joules and the potential energy is 0.4 joules. The amplitude of the oscillation. So we have to find the amplitude. Frequency is given, mass is given, right? So we can find angular frequency by using the frequency, that will be 2 pi f. It will be 2 pi times 25 by pi, which comes out to be 50 second inverse. Now we can use omega and mass to find the force constant. So that is nothing but m omega square. So m is 0.2, omega square will be 2500. So this will give us 500 Newton per meter. Now we got force constant. So kinetic energy is given. So and position is given and potential energy is given. So here we cannot use the formula of potential energy and mechanical energy as it is, because nothing is given about the initial potential energy of the particle. If at the main position potential energy is 0, only in that case the three formulas are applicable, but kinetic energy formula is applicable in any scenario. So that will be half k a square minus x square. And we have given kinetic energy, we know the value of k, we know the value of x, so we can find a from this equation. So kinetic energy is 0.5 and the force constant is 500. Amplitude we have to calculate. X is given as 0.04, or I can write this as 2 by 50 square. Now this half will get cancelled out. So we have 1 by 500 plus 2 by 50 square is equals to a square, right? So let us simplify this. So 1 by 500 plus 4 by 2500 is equals to a square. Now let me take 1 by 500 common. So that will be 1 plus 4 by 500 times 5. So 5. So this will be 1 upon 500 times 1 plus 0.8. So that will be 1.8 divided by 500 is equals to a square. Now let us multiply and divide with 2. So that will be 36 upon 10 raised to power 4. Now from this a comes out to be 6 upon 100, which is 0.06 meters or 6 centimeters. So 6 is the answer. Now let us see the question based on the graph from the same problem type. The variation of kinetic energy of the particle executing simple harmonic motion with the displacement x starting from the main position to the extreme position. Okay, so in this case kinetic energy is given as half times the force constant times a square minus x square. And so if we have k on the y-axis, x on the x-axis, it will be a parabolic function. And since the coefficient of x square is negative, it will be the downward parabola. So it should be, and we have to find the graph from the mean position to the extreme positions. At the mean position, kinetic energy is maximum. At the extreme position, kinetic energy is 0. So it should be option 4, right? A particle is executing simple harmonic motion. The ratio of the potential energy to the kinetic energy of the particle when its displacement is half of the amplitude. So x is given as a by 2, and we have to find the ratio of kinetic energy and potential energy and the kinetic energy. So here I am assuming that the potential energy is 0 when the particle is at the mean position. So let us find this. So it will be half k a by 2 square divided by half k a square minus a by 2 square. So this will give us 1 by 4 divided by 1 minus 1 by 4. So this comes out to be 1 upon 3. So option 4 is the right answer. A particle executes simple harmonic motion of amplitude A. The distance from the main position when its kinetic energy becomes equals to the potential energy. Whereas the answer is A by root 2. That is the general case. So we can say half k x square is equals to half k a square minus x square. We have to equate the kinetic energy with the potential energy. Again, I'm assuming potential energy is 0 when the particle is at the mean position. So half k will get cancelled out. So from this x comes out to be plus minus a by root 2. So option 3 is the right answer. For what value of displacement kinetic energy? Again, same question asked in the different shift. It will be plus minus a by root 2. The amplitude of the particle executing simple harmonic motion is 3 centimeter. So amplitude is 3 centimeter, displacement at which its kinetic energy will be 25% more than the potential energy. Again, I'm assuming that the potential energy is 0 at the mean position. So we have to find the displacement at which the kinetic energy is 25% more than the potential energy. So kinetic energy is half k a square minus x square. It will be 1.25 times half k x square. So half k will get cancelled out and 1.25 can be written as 5 by 4. So 4a square minus 4x square is equals to 5x square. From this 9x square will be 4a square. So x comes out to be 2 by 3a, right? And what we have given amplitude is 3. So that will be 2 centimeters. So 2 is the answer. The general displacement of a simple harmonic oscillator is x equals to a sine omega t. Let t be its time period and the slope of its potential energy u versus time curve will have a maximum when t is equals to t by beta. The value of beta is. So we have to find the value of time. We have to find the time at which the slope to ut graph is maximum. So first let us write down the formula. So u will be half k x square. So I'm assuming that the potential energy is 0 at the mean position. So that will be half k a square sine square omega t. Now we want to find the slope. So if we differentiate this, we'll get the slope, right? So du by dt is the slope. So half k a square, and the differentiation of sine square omega t will be 2 sine omega t times omega cos omega t. Now if I club 2 sine omega t and cos omega t together, it becomes sine 2 omega t. So we can say du by dt can be written as half k a square omega sine 2 omega t. Now we got the slope and we want to maximize this slope. So we're going to use maxima minima concept. So let us take the differentiation. So so let us differentiate this. Let me call this as say x, right? Capital X. Now dx by dt will be half k a square omega, and that will be 2 omega cos 2 omega t, right? So let us put this equals to 0, and we know that cosine function will be 0 at pi by 2, 3 pi by 2, right? Odd multiple of pi by 2. So we can say 2 omega t will be equals to 2n minus 1 pi by 2. Now let us differentiate x one more time. So d square x by dt square will be half k a square, and this will be 2 omega square, and it will be minus of 2 omega sine 2 omega t. And we know that at maxima the second derivative is negative. Okay, now we have to check on what values of 2 omega t the second derivative is negative. So it means this sine 2 omega 2 has to be positive. Okay, so we can say when we take 2 omega t as pi by 2, this this second derivative comes out to be negative. Or if we take 3 pi by 2, then it comes out to be positive. So what we can say, it has to be pi by 2. So 2 omega t has to be pi by 2 for maximum slope. Or we can say t will be pi by 4 omega, and omega can be written as 2 pi by capital T. So that will be pi by 4, and then this will be 2 pi by capital T. So pi will get cancelled out. So this will be t by 8. And if you compare, then beta comes out to be 8 only, right? So 8 is the answer of this question. Now let us see this question. An object of mass 0.5 kilograms is executing simple harmonic motion. Its amplitude is 5, so mass is given, amplitude is given, and time period is also given. What will be the potential energy of the object at an instant t equals to t by 4 seconds, starting from the main position? So there are two approaches. Either you can directly write the potential energy as a function of time, or you can find the position of the particle at t equals to t by 4, and then use the relation of the potential energy in terms of x. So let me first find the position. At t equals to t by 4, it means 1/4 of the oscillation. X will be nothing but a. So particle is at the extreme right because it is starting from the main position. And I'm assume the initial phase of the oscillation is 0. So it is starting from the main position going in the right direction. So at t equals to t by 4, it will be at the extreme right. And we know the x, and we have to find the potential energy. And here again I'm assuming that the potential energy is 0 at the main position. So I'm going to use half k x square formula for the potential energy. So it will be half, and what is k? K is m omega square, and omega is 2 pi by capital T times x, which will be a. So let us simplify this. Mass is 0.5 divided by 2, and this will be 4, and this will be pi square divided by t square, and t square is, so t is given 0.25, so t square will be 1 by 25. So this will be 25 here. Okay, right. So a is 5 centimeters, so that will be 25 into 10 raised to power minus 4. Okay, now let us find the approximate answer because options are quite far apart. So that will give us 2 and 0.5 will be 1. So we have pi square times 625 into 10 raised to power minus 4. And pi square is nearly equals to 10. So this will be 625 into 10 raised to power minus 3, or 6.25 into 10 raised to power minus 1. Or we can say it will be 0.625 joules. So option 1 is the closest answer. So that is the answer of this question. Okay, let's see the next question. A particle starts executing simple harmonic motion of amplitude A, total energy E. At any instant, its kinetic energy is 3e by 4. Then its displacement y is given as. So we have given kinetic energy 3e by 4, and we know that the kinetic energy is half k a square minus y square, right? Where y is the displacement from the main position. Now total energy is given as E, and if I assume potential energy to be 0 at the main position, then total energy can be written as half k a square. So this can be written as, or from this we can say k is nothing but 2e by a square, right? And we have to find the value of y. So E is so 3 by 4, E is half k a square. It is equals to half k a square minus y square. So this k by 2 will get cancelled out, and we have 3 by 4. 1 minus 3 by 4 a square will give us y square. So that will be a by 2 plus minus. So option 4 is the right answer. Right. Now let's see the next question. A block is fastened to a horizontal spring. The block is pulled to the distance x equals to 10 cm from its equilibrium position on a frictionless surface from rest. The energy of the block at x equals to 5 cm is 0.25 joules. The spring constant. So we have given energy and we know that the energy will be given as half k a square, and if we assume potential energy to be 0 at the main position, and this is given as 0.25. K is mass is not given, and we have to find the energy. Okay, so what we can do, even omega is not given, mass is not given, amplitude will be nothing but 10 centimeters. So k will be k by 2. A is 0.1 because we have released the block when it was at rest. It means we have released it from the extreme right position. So that will be 0.1 square and this will be 1 by 4. So this will give us 2. So K comes out to be 50 Newton per meter, right? So that is the answer. Now let us see the next problem type, which is based on spring block arrangements. A mass M is suspended from the spring of negligible mass and system oscillates with a frequency f1. The frequency of oscillation if mass 9m is suspended from the same spring is f2. What is the ratio of the frequency? So we know that angular frequency is given as root of k by m, or frequency will be given as 1 by 2 pi root k by m. So for a given spring constant, the frequency will be inversely proportional to square root of the mass. So f is inversely proportional to square root of mass. So f1 by f2 will be equals to root of m2 by m1. And what is m1? m1 is m, m2 is 9m. So that will be 9m by m whole root, which is 3. So the answer will be 3. As per the given figure, two blocks each of mass 250 grams are connected to a spring of spring constant 2 Newton per meter. If both are given velocity v in the opposite direction, then the maximum elongation of the spring. So this is a 2 block and a spring system. And just let me tell you the time period of oscillation. So time period of oscillation will be given as 2 pi root mu by k, where mu is known as the reduced mass, and it will be m1 m2 upon m1 plus m2. But in this question, we have to find the maximum elongation. Now, when we give velocity v in the opposite direction, both have speed v in the opposite direction, then we can say these are their equilibrium positions. Not equilibrium position where they have the maximum kinetic energy. And let us say this is the extreme position for the right block, and this is the left extreme position for the left block. So if this displacement is A, we can say since both have the same mass, this displacement is also A. So if you are able to find A, if you double that, we'll get the maximum elongation in the spring. So let us first find A. So this is the mean position. So this is nothing but V max. So V max is A omega. It will be A omega, and omega in this case will be root of K by mu. So we can write this as A root of K by mu. That will be nothing but V. And twice of A is V, twice of V times root of mu by K. So let us put the values. So 2V, and mu in this case will be, mass is same, so that will be m by 2, which will be 250 divided by 2, so 125 grams. So we can say 125 times 10 raised power minus 3 divided by K, which is given as 2. So this comes out to be 62.5, or we can write this as 2V and root of 625 times 10 raised power minus 4. So which will be 2V times 25 into 10 raised power minus 2. So this will be 2V times 25 by 4, sorry, by 100. That will be 1 by 4 and V by 2. So option B is the right answer. Now let's see this question. The motion of a mass on a spring with spring constant K is shown in the figure. The equation of the motion is given by x equals to a sin omega t plus b cos omega t, where omega is root of K by m. Suppose that at t equals to 0, the position of the mass is x at t x0 and velocity is v0, then its displacement can also be represented by x equals to c cos omega t minus y. Right, so let us see. So we have given x as a sin omega t plus b cos omega t, and we want to show this in terms of c cos omega t minus y. So for that we need to find what is a and b. Let us do that. So we know that when t is 0, then x is x0, value of x at t equals to 0 is equals to a0 plus b. So we can say b is nothing but x, value of x at t equals to 0. Now if you put if you find the velocity, so v is nothing but A omega cos omega t plus B minus omega sin omega t. So V at t equals to 0 will be what? It will be A omega plus 0. Okay, so from this equation we know what is B. B is nothing but x, value of x at t equals to 0, and from this we got A omega as value of V at t equals to 0. Okay, so now what we can do, so we know the value of B, so it can be written as, x can be written as A will be, omega is given as root of k by m, so it will be A is value of V at t equals to 0 divided by omega, so x will be A, and A is V0 by omega times sin omega t, plus, and B is x at t equals to 0 times cos omega t, right? Now what we can do, we want to write this in terms of cos, right? So how we can, so let us say, let us divide and multiply with root of V0 by omega square plus x0 square. So I'm dividing and multiplying with this. So this will become root of V0 square divided by omega square plus x0 square, and we have V0 by omega divided by root of V. Okay, let me just take it at some constant, right? No need to write it multiple times. So I'm taking this as, say, capital T, right? So this will become t divided by t sin omega t plus x0 divided by t cos omega t, right? Now if you look at this and this factor, I can call this factor as sin alpha and this as cos alpha. Why I can write it like this? Because sin square alpha plus cos square alpha will come out to be 1. So we can write it like this. So this will become t, and where t is this value, it will be cos omega t minus alpha, right? And now we have written x in terms of cos, and alpha is, so let us find the alpha. So tan alpha will be V by omega divided by x, value of x at t equals to 0, and t is nothing but root of this, right? So let us see the option, which option is correct. So option 4 is matching with our answer, right? So option 4 is the right answer. Okay, two particles A and B of equal masses are suspended from the two massless springs of spring constant K1 and K2. If the maximum velocity during oscillation are equal, the ratio of the amplitude of A and B. So V max in the first case is same as V max in the second case, and we know that V max is A omega. So A1 times omega, and omega is root of K by M, root of K1 by, and masses are same, right? So M, and V2 will be, it will be A2 times root of K2 by M. So M will get cancelled out. So A1 by A2 will be root of K2 by K1. Option 4 is the right answer. For a simple harmonic motion in a mass spring system shown, the surface is frictionless when the mass of the block is 1 kg. The angular frequency is omega 1. When the mass is 2 kg, the angular frequency is omega 2. The ratio of omega 2 and omega 1. Omega is given as root of K by M. And for a given spring, omega is inversely proportional to square root of the mass. So omega 2 by omega 1 will be equals to root of M1 by M2. And M1 in this case is 1 kg, M2 is 2 kg, so that will be 1 by root 2. So option 2 is the right answer. A mass m attached to free end of a spring executes simple harmonic motion with a time period 1 second. If the mass is increased by 3 kg, the period of oscillation increases by 1 second. So period of oscillation is earlier it was 1 second, then it becomes 2 seconds when we have increased the mass by 3 kg. So earlier the mass, let us say, was m, then it has become m plus 3. And we know that the time period is given as 2 pi root m by k. So for a given say force constant, the time period will be directly proportional to square root of the mass. So we can say 2 by 1, that is T2 by T1, will be equals to root of m plus 3 upon m. Let us square it. So 4 is equals to m plus 3 by m. So this will give us 4m minus m equals to 3. So m comes out to be 1 kilogram. So it will be 1. A mass m attached to a free end. Oh, it is the same question. Okay, the time period of a simple harmonic motion of mass capital M in the given figure is pi times root of alpha m by 5k. So that is the time period where the value of alpha is. Now here we have a series and parallel combination. This is the another problem type, series and parallel. So when we have springs in series or in parallel, we should add the spring constants. But if we have springs in series, then we can write 1 by k1 plus 1 by k2 is equals to 1 by k equivalent, right? Or if they are more than 2 springs, then 1 by k3 term will also be added. So we can say these two springs are parallel. First we have to find the equivalent spring constant for this system. So this comes out to be 2k because they are in parallel. Now this 2k and this k are in series. So these two are in series. So we can say it will be 2k by 3, right? Now this 2k by 3 and this k are in parallel. So that will become 2k by 3 plus k, and that will be 5k by 3. Now we got the equivalent spring constant, and we have to find the time period. So time period is 2 pi root m upon k equivalent. So that will be 2 pi root, and m divided by k equivalent will be 5k by 3. So if we compare our result with this expression, alpha comes out to be, okay, it is 5 now, right? And there is a 2 also, right? So let us take this 2 inside. So this can be written as pi root 3 times 4 m by 5 k. So alpha, this is the alpha, right? 12. So 12 is the answer. Now let us see this question. So a mass m is attached to the spring as shown in the figure. The spring constant of the two springs are k1 and k2 for the frictionless surface. The time period of the oscillation. Now this combination is nothing but the parallel combination. So here the equivalent spring constant will be k1 plus k2. So and we know the time period is given as 2 pi root m by k equivalent. So the option 3 is the right answer. Right, let us see this question. In figure A, mass 2m is fixed on mass m, which is attached to the springs of spring constant k. In the figure B, mass m is attached to the two springs of spring constant k and 2k. If mass m is in A and B are displaced by a distance x horizontally, then release the time period. So basically we have to compare the time periods. So in this case, since these two springs are connected in parallel, so k equivalent in this case will be 2k. Here they are connected in parallel, so the k equivalent will be 3k. So we have to just add the spring constants. So in the first case, T1, time period will be 2 pi root m by k. What is the total mass which is oscillating? 3m. So that will be 3m by 2k. And in this case, T2 will be 2 pi root m by k, where total mass is m only, and the equivalent spring constant is 3k. So we have to take the ratio. So T1 by T2 will be root of 3 by 2 times root of 3 by 1. So that is nothing but 3 by root 2. So option A is the right answer. Another illustration based on the same concept. As per given figures, two springs of spring constant k and 2k are connected to a mass m. If the period of oscillation in figure A
is 3 seconds, then the period of oscillation in figure B will be, so this is series combination, so it will be 2k by 3 equivalent spring constant, and this is a parallel combination, so that will be 3k. We have to just add them. So in this case the time period is given as 3, so 3 is 2 pi root m by 2k by 3, right? And in this case we have to find the time period, so time period in B will be 2 pi root m by 3k. Now from this we can find the value of m by k, root of m by k. So we can say root of m by k will be equals to 3 by 2 pi times root of 2 by 3. Now let us substitute this value in this, right? So TB comes out to be 2 pi by root 3, and that will be 3 by 2 pi times root of 2 by 3. So 2 pi will get cancelled out, and this root 3 will cancel out this 3, so this comes out to be root 2. So x will be 2, right? So 2 is the answer. Now let us see this question. So here we have given two bodies A and B of mass 200 grams and 800 grams are attached with the system of the springs. Spring are given are kept in a stretched position with some extension when the system is released. The horizontal surface is assumed to be frictionless. The angular frequency with which okay, right. So we have to find the angular frequency of oscillation. So I told you when we have two springs, so now we have two springs in series, so K equivalent will be 4k square divided by 5k, so that will be 4k by 5. So we got the equivalent spring constant. And what is the reduced mass of this system? That will be m1 m2 upon m1 plus m2. So this comes out to be 200 times 800 divided by 1000. So it is 160 grams. So we got the reduced mass. Now the angular frequency will be given as root of K equivalent by mu. So what is K equivalent, which is 4 by 5k, and K is given as 20 and mu is 160 grams. So 160 divided by 1000. So this will give us 40 and this will give us 2. So 5 into 2 will be 10. So we are getting 10. So angular frequency will be 10 radians per second. So that is the answer. Now let us see this question again. Okay, right. Consider two identical springs, each of spring constant K and negligible mass, compared to the mass capital M. Figure 1 shows one of them and figure 2 shows their series combination. So we have two identical spring, right? If this is K, this is also K, this is also K. Now the ratio of the time period of oscillation of the two SHM is TB by TA, which is root x, what is the value of x? Okay, right. So what is TA? TA will be 2 pi root m by k. Now in this case these are in series combination, so the K equivalent will be K by 2. So here TB is 2 pi root m by k by 2. So can you see it is root 2 times of TA. So TB is root 2 times TA. So x will be 2. So 2 is the answer. Right, so in the given figure, a body of mass m is held between two massless springs on the smooth inclined plane. The free end of the spring are attached to the firm support. If each spring has a spring constant K, find the frequency of oscillation of this body. Right, so here we have this given this arrangement. So we can say these two springs which are in parallel combination, right? Because in this case K equivalent comes out to be K1 plus K2. It doesn't matter whether we have this arrangement inclined or it is horizontal or it is vertical. In all the cases the time period will come out to be same, and or the frequency of oscillation will come out to be same, right? So the frequency will be 1 by 2 pi times root of K by M. So it will be K1 plus K2 divided by M. So that should be the answer, and both have same spring constant, so that will be 2K. So 2K by M. So option 3 is the right answer. Two identical springs of spring constant 2K and are attached to the block of mass M to a fixed support. When the mass is displaced from the equilibrium position on either side, it executes simple harmonic motion. the time period of oscillation. I told you like in this case these are in parallel combination, so K equivalent will be 4K. So time period will be 2 pi root m by 4K, and 4 will come out, so we'll get pi times root of m by K. Option 4 is the right answer. Okay, similar question. I'm keeping this question as a homework that you can try. If two similar springs, each of spring constant K1, are joined in series, the new spring constant and the time period would be changed by the factor of. Okay, right. So we know that when we have two springs in series, the effective K equivalent will be given as K1 K2 upon K1 plus K2. Now in this case, both the spring have the same spring constant, so this will become K1 by 2. Now, so we can say the spring constant will be decreased by the factor of 2, and so it means option 2 and option 3 are incorrect. And now we have to also find the what happens to the time period. We know the time period is given as 2 pi root m by K. So time period is inversely proportional to square root of the spring constant if for the given mass. So time period is inversely proportional to square root of K. So we can say as K has decreased by the factor of 2, spring constant time period will increase by the factor of root 2. So the new time period T2 will be root 2 times the T1. So option 1 is the right answer. Okay, mass. Now this is the question based on another problem type, momentum conservation in spring block arrangement. Let us see. A mass 0.9 kilogram attached to a horizontal spring executes simple harmonic motion with an amplitude A1. When this mass passes through the mean position, then a smaller mass of 124 grams is placed over it and both the masses move together with the amplitude A2. If the ratio A1 to A2 is alpha upon alpha minus 1, then what is the value of alpha? Okay, let us see what we have given. So here we have given a block of mass 0.9 kilograms. And let us say this is the mean position. And it is 0.9 kilograms. Spring constant is not given. Let us take it as K. Now when it is crossing its mean position and the amplitude is also given, that is A1. When it crosses the mean position, velocity will be maximum. So at this instant, the velocity, let me call this as V1. It will be A1 times omega 1, and omega 1 in this case will be root of K by M. Root of K by M. Now what we're going to do, we have placed a block of 124 grams over it. So when we do that, when we place a block of mass 0.124 kilograms over it, at this very instant there is no external force acting on the system in the horizontal direction, so we can conserve linear momentum in the horizontal direction. So when we do that, mass of the system has increased, so the speed will decrease. Let us see. So if you conserve linear momentum, what is the momentum just before placing the block? It will be 0.9 times the velocity, which is A1 omega 1. And after that, let us the velocity will become what? It will become V2. So V2 times total mass, it will be 0.124 plus 0.9. And what is this V2? Again, the spring is having zero elongation. So we can say this will be the mean position of the new system. And this V2 is nothing but the maximum velocity of that system. So this V2 can be written as A2, that is the new amplitude, times the new angular frequency, and omega 2 will be given as root of K by total mass, which will be this will be 1.024. Right? Now let us substitute these values. So we have 0.9 times A1 times root of K by 0.9, and that will be equals to A2 times root of K divided by 1.024 times, it will be 1.024. Now we can eliminate root K. So A1, so A2 will be so if I simplify this, this will become A2 will be root 0.9 divided by root 1.024. Right? So let us simplify this. And we have to find the ratio. Okay, right. So let us find the ratio. A2 is equals to root of 0.9 upon root of 1.04 times A1. So A1 by A2. So A1 by A2 will be root of 1.024 divided by root of 0.9. I hope this is clear. Now let us simplify this, and we have given it is alpha upon alpha minus 1. So it is alpha upon alpha minus 1, right? So it will be root of 1024 divided by 900. And if I divide this, so this can be written as, okay, let me simplify this further. So root of this can be written as 2 raised to power 10, and this will be 30 square, and it is given as alpha upon alpha minus 1. So we can say 2 raised to power 5 divided by 30, which is 32 divided by 30 alpha upon alpha minus 1. So we can say 32 alpha minus 32 is equals to 30 alpha. So 2 alpha will be equals to 32. So alpha comes out to be 16. So 16 is the value of alpha. In a given figure, a mass m is attached to a horizontal spring which is fixed on one side to a rigid support. The spring constant of the spring is k. So mass is m, spring is constant is k. The mass oscillates on a frictionless surface with a time period capital T and the amplitude a. When the mass is in equilibrium position as shown in the figure, another mass m is gently fixed upon it. The new amplitude of the oscillation. Again, it is based on the same concept that we've just studied in the last question. So what we can do, it will be again just before placing the blocks of mass small m over capital M, the velocity v1 will be, it will be a omega 1, right? And omega 1 will be root of k by capital M. And after placing it, the velocity will become, let us say, a prime omega 2, and omega 2 will be root of k upon total mass, that will be capital M plus small m. Okay, and if we conserve linear momentum when the system is in equilibrium position, it will be capital M will capital M times v1, which will be a times root of k by capital M, equals to capital M plus small m times a prime times v2, which is omega 2 will be root of k by m plus small m. Now root k will get cancelled out, and this can be written as a times root of capital M, and this can be written as a prime times root of m plus small m. So a prime comes out to be a times root of m upon m plus small m. So if you look at the option 2 is the right answer. Now let us see the next problem type, and it is based on the time period of a simple pendulum, and we know the formula. Time period is given as 2 pi root L by G, where L is the length of the pendulum and G is the acceleration due to gravity. Choose the correct length versus square of the time period graph. Okay, right? So we have to see the graph of L versus T square. So if you square this, so L will be equals to T square by 4 pi square times G. So we can say L is proportional to T raised to power 2. So it will be, if we plot it, it will be a straight line. Okay, and the slope is positive, so it will be option 3, and it is a straight line passing through the origin. So option 3 is the right answer. T0 is the time period of a simple pendulum at a place if the length of the pendulum is reduced to 1/16th of its initial value. It means if the original length is L, it has become L by 16. The modified time period. So we know that time period is given as 2 pi root L by G. So it is directly proportional to square root of the length for given acceleration due to gravity. So we can say T2 by T0 will be equals to root of L by 16 divided by L. So from this we can say T2 comes out to be T0 by 4. So option 4 is the right answer. Given below are two statements. Statement 1, a seconds pendulum has a time period of 1 second. Second statement is it takes precisely 1 second to move between the two extreme positions. So in order to answer this question, we should know what do we mean by the seconds pendulum. A seconds pendulum has a time period 2 seconds and it is having a length 1 meter. If you substitute length as 1 meter in the time period formula, you will get time period as 2 seconds. So it means the half oscillation time is 1 second. So statement 1 is incorrect. It has a time period of 2 seconds. It takes precisely 1 second to move between the two extreme positions. That is correct because the overall time period is 1 second. 2 seconds. So in the light of the above statement, so we can say option 2 is the right answer. Statement 1 is false. Statement 2 is correct. Right, we have just discussed this question. where option 3 is the right answer. So usually they'll give the same question in 2 different shifts. So that can happen in, it is quite, you can say, frequent in JEE Mains, and they can give the same question. Now let us see the next problem type, which is based on the variation of the time period with the acceleration due to gravity. A simple pendulum is placed at a place where its distance from the Earth's surface is equal to the radius of the Earth. If the length of the string is 4 meters, then the time period of oscillation will be. So first of all, we should know how to find the acceleration due to gravity at a particular altitude. So here we have given that the pendulum is placed at a distance r from the surface, where r is the radius of the Earth, and we know that the acceleration due to gravity is given as gm divided by 2r. That 2r is 2r square, where 2r is the distance from the center of the Earth. So this can be written as gm divided by 4r square, which is nothing but g by 4, where g is the acceleration due to gravity on the surface of the Earth. So what you can see, the value of g has decreased by the factor of 4. And we know that time period is inversely proportional to square root of g. So since the g has decreased by the factor of 4, time period will increase by the factor of 2. So the new time will be 2 times the original time. And what we have given, length is given, and then the time period of oscillation. Okay, right, we have to find the actual time. So it will be t 2 pi root, length is given as 4, and g we have to take pi square divided by 4. So this comes out to be 2 pi root 16 by pi square, which can be written as 2 pi times 4 by pi. Pi will get cancelled out, so the answer will be 8 seconds. Now let us see the next question. The time period of simple pendulum in a stationary lift is t. If the lift accelerates with value g by 6 vertically upward, then the time period. So when so now here the lift is accelerating. So here we have to consider effective g in the frame of the lift, and this effective g is what, every particle in that lift is experiencing a pseudo force in the since it is accelerating in the upward direction, it will be in the downward direction. So effective g will be g plus the acceleration of the lift, so g by 6. So that will be 7g by 6. So the time period will be 2 pi root L by g effective. So L, okay, right, so L by g, that is the formula, and we have to compare the time periods, right? So when the lift is not moving or when the lift is moving, so we can say t2 by t1 will be square root of, it will be you can say g1 by g2, right? Because time period is inversely proportional to the acceleration due square root of the acceleration due to gravity. So t2 divided by t is equals to root of g divided by g by 7g by 6. So this comes out to be 6 by 7, root of 6 by 7. So time period will be t times root of 6 by 7. So option C is the right answer. The time period of an oscillation of simple pendulum of length L suspended from the roof of a vehicle which moves without friction down an inclined plane of inclination alpha is, okay, let me first draw the diagram. So here we have given an inclined plane, and this inclination is alpha, and it is going down, right, smoothly without friction. If it is without friction, then the acceleration of this we have a vehicle, right? Acceleration of this vehicle is g sine alpha. So if I consider a pendulum which is suspended from the ceiling, on this pendulum there will be a pseudo force which is up the incline, and there will be a gravitational force which is in the downward direction. So this pseudo force will be mg sine alpha, and this will be mg, and now it will incline such that, okay, right, now it will due to this pseudo force the string will not be perpendicular to the wall of the vehicle. Now they will be tilted, right? So if I show you the actual orientation of the pendulum, it will be something like this, right? Where this force is mg sine alpha, and this will be mg, and we have to find mg is in the downward direction. Mg is in the downward direction, and we have to find the time period. So how to find the effective G in this case? So effective G is the tension in the equilibrium position divided by the mass of the bob. So what is the tension in the equilibrium position? That will be the resultant of these two vectors, because the tension will be balancing the resultant of these two forces if you consider the bob in the frame of the vehicle. So what is T? So it is the resultant of these two. And what is the angle between them? If this angle is alpha and this is 90, so the angle between these two vectors is alpha plus 90. So the resultant will be mg sine alpha square plus mg square plus 2 mg square sine alpha cos of alpha plus 90. So I have used the resultant formula. So that will give us the tension in the string in the equilibrium position. Now let us simplify this. Mg will come out, and then this will be sine square alpha plus 1 plus 2 times, and cos 90 plus alpha is minus sine alpha. So that will be 2 times minus sine square alpha. So this will become 1 minus sine square alpha, root of 1 minus sine square alpha times mg. So it will be mg times root of cos square alpha. So this comes out to be mg cos alpha. And this is the tension in the equilibrium position. Now let us divide this with the mass, and this will give us the effective G. So it will be G cos theta. So the time period will be 2 pi root L by G effective, which is G cos alpha. So option A is the right answer. Now let us see the application of simple harmonic motion in other chapters. So this is the application in electrostatics. Let us see the question. Two identical positive charges Q each are fixed at the distance 2a apart from each other. Another point charge Q0 with a mass m is placed at the midpoint of the two fixed charges. For a small displacement along the line joining the fixed charges, the charge Q0 x along the line, right? Along the line joining. The charge Q0 executes simple harmonic motion. The time period of small oscillation of the charge Q0 will be. First, let me show you the situation. So we have given two fixed charges, capital Q and capital Q, and the distance between them is given as 2a. And there is a charge Q0 which is placed, again all the charges are positive, and there is a charge Q0 which is placed at the midpoint. Now what we have done, we have displaced this charge slightly, let us say in any direction, right, along the line joining the two fixed charges. Let us say we have displaced it in the left direction. Now that is Q0. And let us say the displacement is x, and this x is very small. So what we can say, the distance of small Q0 from the left charge will be a minus x, and the distance of small Q0 from the right charge will be a plus x. Now what we're going to, will see what is the net force experienced by the charge when we have displaced it, and we'll try to make it proportional to the displacement from the mean position. So let us find the resultant force. Since Q0 is closer to the left charge, it will feel a much stronger repulsive force. So we can say the restoring force in this case will be negative of K Q Q0 divided by a minus x square minus K Q Q0 divided by a plus x square. I have just applied Coulomb's law. Now let us take the K Q0 and Q and a square common. So we'll get 1 upon 1 minus x by a square minus 1 upon 1 plus x by a square. Now we're going to use the approximation, binomial approximation, because x is very small in comparison to a, because we have slightly displaced the charge. So it can be written as, so FR can be written as minus K Q Q0 divided by a square. This will be 1 plus 1 minus x by a raised to power minus 2 minus 1 plus x by a raised to power minus 2. Now let us use binomial approximation. So this 1 minus x upon a raised to power minus 2 will become 1 plus 2 times x by a. 1 plus 2 times x by a. And this will become 1 minus 2 times x by a. So we got the relation. So this 1 will get cancelled out, and we will get minus, and the answer is given in epsilon naught. Let me write k in terms of epsilon. So it will be q times q0 divided by 4 pi epsilon naught times a square times 4x by a. So which is nothing but q naught q naught divided by pi epsilon naught times a cube times x. So that is Fr. So we got the restoring force which is proportional to the displacement from the main position, and we have to find the time period. So this is nothing but the force constant. This is k, right? So we got k, and we know that the time period will be 2 pi root m by k. So let us put the values. So 2 pi root m, and the k is q naught by pi epsilon naught a cube, and let us take this 2 pi into the square root. So we will get 4 pi cube m epsilon naught a cube divided by q naught. So that is the option. Option A is the right answer. The metallic bob of simple pendulum has a relative density 5, and the time period of this pendulum is 10 seconds. If the metallic bob is immersed in water, then the new time period becomes 5 times root x. We have to find the value of x, right? So what is happening in this case? When we submerge the setup in water, then the bob will experience a buoyant force, and due to that we can say the tension in the equilibrium position will change. So there is a string, this is the bob, and let us say at this very instant when the string it is in the equilibrium position, we need to find the effective G, right? So effective G will be the tension in the equilibrium position divided by the mass of the bob. Now what is the tension? So there will be a gravitational force acting in the downward direction, that will be mg, and there will be a buoyant force which will be Fb. So the tension is mg minus Fb. Okay, so what is mass? Let us say sigma is the density of the body of the bob, and rho is the density of water. So m can be written as sigma times the volume, let us say V is the volume of the bob, times G, and Fb can be written as the density. So to calculate buoyant force, we have to consider the density of the surrounding fluid, which is rho, and the submerged volume, which is nothing but the total volume of the bob, which is V times G divided by m, and m is nothing but sigma times V. So can you see V will get cancelled out? So this will be sigma minus rho divided by sigma times G. And we have given sigma by rho as 5. So this can be written as 1 minus rho by sigma times G, and this will be 1 minus 1 by 5. So effective G is 4 by 5G. So the time period, original time period was 10 seconds. So T2 by T1 will be equals to root of G1 by G2. And original G is G only, and the new G is 4 by 5G. So which is root of 5 by 4. So T2 will be T1 times root 5 by 2, and T1 is given as 10 seconds. So that will be 5 root 5 seconds. So if you compare this, X comes out to be 5. So 5 is the answer. Now let us see this question. Assume that the earth is a solid sphere of uniform density, and a tunnel is dug along its diameter throughout the earth. It is found that when a particle is released in this tunnel, it executes simple harmonic motion. The mass of the particle is 100 grams. The time period of the motion of the particle will be. So here we have to find the time period, and we have given earth, assume earth to be a uniform sphere, uniform solid sphere, and we have created a tunnel which is passing through the center of the earth. Okay, right. So let us say when the particle is at a distance x from the center of the earth, let us find the force experienced by this particle. Let us say force is F. Now this F will be given as, so the field or you can say the gravitational field at this location at a distance x will be given as Gm x divided by r cube, where r is the radius of the earth, mass m is the mass of the earth, x is the distance from the center. And if I multiply this with the particle's mass, we will get the force experienced by the particle mass. Since if you displace the particle from the center, say in the upward direction, it will experience a force in the opposite direction. So let me put a negative sign here. So this F will be the restoring force. So we can say F is equals to minus gm small m by r cube times x. Now this factor is nothing but the force constant k, and we have to find the time period, which will be 2 pi root m by k. Mass of the particle divided by k, and k is g capital M small m by r cube. And we have given value of g, and we know that g m by r square is 10. That is the acceleration due to gravity on the surface of the earth. So this can be written as 2 pi root r divided by 10. And what is r? R is given as 6400 kilometers. So it will be 2 pi root 6400 into 10 raised to power 3 divided by 10, and this will be 2 pi times 80 times 10. So it will be 1600 pi, and we have to find answer in terms of hours. So we have, this is in seconds. So 1600 pi divided by 60, it will give us minutes, and further 60, it will give us hours. So let us simplify this. So this will be 1600 times pi divided by 3600, and we are getting 1.396 hours, or we can say 0.396 into 60 plus 1 hour, right? So it will be 0.396 times 60, so it will be 23.75. So 1 hour 24 minutes. So option 2 should be the right answer. Right, so let us say this question: a particle of mass 1 milligram and charge q is lying at the midpoint of the two stationary particles kept at the distance 2 meter when each is carrying a same charge q. If the free charge is displaced from its equilibrium position through the distance x, the particle executes simple harmonic motion, its angular frequency of oscillation. This question is based on, let me just show you that question. So we have done this question. So this particular question is based on the same concept. You can try this question, and the answer is given as 6, right? And here we have to find the angular frequency. Now let us say this question: assume that the tunnel is dug along the chord of the earth, a perpendicular distance r by 2 from the earth's center, where r is the radius of the earth. The wall of the tunnel is frictionless. If the particle is released in this tunnel, it will execute simple harmonic motion with the time period. So here we have to find the time period, and in this case the tunnel is made at a distance r by 2 from the center. Let me show you the tunnel. It is being made. Let us, this is the tunnel, and this distance is r by 2. And if the particle, let us say, is at a distance x, then in this case, so what will be the force experienced by this particle? So we can say it will experience force towards the center of the earth. There will be a gravitational force. Let me call this as Fg. Apart from this, it will feel the normal reaction by the tunnel in the downward direction because it is pressing the tunnel in the upward direction. So there will be a normal reaction in this direction. Okay. Now this gravitational force experienced by the particle will have two components. One will be along the tunnel, other will be perpendicular to the tunnel. The component which is along the tunnel will act as the restoring force, whereas the component which is perpendicular to the tunnel will balance the normal reaction. So we're going to take this component, right? Let me just magnify this. So there is a force Fg, and its component in this direction will be, let me call this as F parallel, and this component will be F perpendicular. So we are concerned with the F parallel component, and I'm taking this angle as theta. So this angle is theta, and let us say the distance of the particle from the center is r. So this Fg will be gm small r divided by r cube times the mass of the particle that we have just seen, like in one of the question. And what is the component in the along the tunnel? So F parallel will be gmr upon r cube times m times cos theta, and cos theta will be base upon hypotenuse, and hypotenuse is r, so r will get cancelled out. So this comes out to be gm by r cube times mx. This will be F parallel. So we can put a negative sign here, because if you displace the particle to the left from the center of the chord, it will experience a force in the right direction. So this factor is nothing but the force constant k. So the time period will be 2 pi root m by k. M by k, and k is g capital M small m by r cube. Small m will get cancelled out, and we can write r cube by gm as r times r square by gm. So it will be 2 pi root r by g, because gm by r square is nothing but acceleration due to gravity on the surface of the earth. So option 3 is the right answer. Now let us see the last problem type, and it is based on the superposition of two simple harmonic motions. So two simple harmonic waves having equal amplitude 8 cm, equal frequency 10 Hz are moving along the same direction. The resultant amplitude is also 8 cm. The phase difference between the individual waves is, so we have to find the phase difference. So here you can simply use the superposition. Right, so we can say if both have the same amplitude, then the resultant amplitude will be given as 2a cos phi by 2. So, right, so I have used resultant formula only, and this resultant amplitude is given as 8 cm. So 2 times, and this is also 8 cm cos phi by 2. So 8 will get cancelled out. So 1 by 2 is equals to cos phi by 2, and we know that we'll get 1 by 2 for it is the cosine value at angle 60 degrees. So we can say cos pi by 3 will be equals to cos pi by 2. So from this, phi comes out to be 120 degrees, right? So 120 is the answer of this question. So here I conclude this video. So I hope you must have learned something new. If you find videos of this series useful, so it is highly recommended for you to join PracBee's revision program. So in this program, we're going to cover 10 blocks in 10 weeks, and we'll give you a target of 1 chapter per day, and we'll be able to cover all relevant chapters by the first attempt of JEE Mains. And how you can join this revision program? By clicking on the link given in the description. And one more thing you can do, please drop a comment. Let us know what else we can do for you to make this series better. Thank you.